Extended ACL configurations. As you know from previous slides, extended ACL got a lot of filtration options of the packages, including source and destination IP addresses, destination port number, and filtration by the protocol which is working, IP, TCP, or UDP, or ICMP. And in our scenario, we have to make configuration of the network so that PC1, PC0 will be able to communicate with server 1. So now we can make filtration from and to, so that PC1 will be able to communicate with server 0. But PC1 will not be able to communicate with server 1. Not able and able. And whereas second part of the ACL is saying that permit PC1 to communicate with server 1. So PC1 is able to communicate with server 1, but PC1 is not able to communicate with server 0. Okay. How to create the extended ACL? We have to be sure that we remember these numbers, so that extended ACL IDs are from 100 till 199, so that we can create access list from global configuration mode and access list 111. It is in the range of these two numbers. And then we are writing also permit. So we have two variants. We can write permit or we can write deny. And after what, we have to define the protocol. So we are defining IP protocol, but here we have different variants. We can include in configuration, for example, TCP, or we can use UDP, or you can use IP, or you can use ICMP, or you can use different types of protocols like EIGRP and so on. Okay. These are variants which can be used in this syntax after permission. In case if you are selecting IP, so that you have to remember that we have 7 layers of OSI model. 4, 3, 2, 1. And on layer number 4, we have a transport layer. We have protocols UDP and TCP. In third layer of our model, we have IP protocol. So that when you are selecting IP protocol, you are selecting both of them, TCP and UDP. Okay? And when you are selecting IP protocol, you cannot make filtration by port number, by destination port number. And in our example, we have to we have to permit only from IP address to IP address. And we have to deny from IP address filtration to IP address. We don't have to deny from IP address and to IP address and plus port number. In this example, we are not using port numbers. That is why we are selecting IP. And then, guys, we are writing host and defining our host. This is PC0. So we are permitting IP communication from PC0, and here is, this is like the first IP address from. The second IP address here is defining server 0. It is 2. From PC0 to server 1, permit. Our second row will deny IP communication from PC0 to server 1. PC0 denied to communicate with server 1. Next, our rule will say that permit host IP host communication of the PC1 to server 1. PC1 is able to communicate with server 1. And our last rule will say that IP communication from host PC1 deny to make communication with server 0. And then we'll implement this rule to gigabit 00 interface as inbound ACL. And by the way, here we have additional rule which we will not type, but it will be used by a router. It will be access list 111 deny IP any. And for all other equipments from any IP address to any IP address communication will be denied. And let's try to make this implementation so that we have with you router 1, and router 1 will be configured with these rules, with this scenario. So that we have to create access list at the beginning, and then we have to say that permit, and we are able to select, you see here, different types of protocols. We define that we have to use IP protocol, so we are saying that access list 111 permit IP communication from host 192.168.10.4 and to host 192.168.20.4. Then we'll say that deny IP communication from host 10.4 to host 25, and then we'll permit communication for host 10.5 to host 25, and then we'll deny communication from host 10.5 to host 10.4. And at then we'll go to gigabit 00 interface and we'll say that IP access group 111 in. And now let's try to make communication from PC 0 to server 0, so that, and we'll also take a look for our rules which are written here, so that PC 0 have to be able to communicate with server 0. And we can see here that our communication is successful. Next, our task is to deny PC 0 to communicate with server 1. And as you see here, it is failed. Next, our test will be PC 1 is able to communicate with server 1. And as you see, it is successful to do it. And next, our rule, PC 1 is not able to communicate with server 0, and this failed. So our rules are satisfied, and I think that we created with you a good configuration according to scenario. So that if you'll take a look for your running configuration file, you can find out here these rules. And by the way, I didn't delete my access list 20, but it is not in use because currently I'm using only access list 111 in gigabit 00 interface. And if you'll take a look for your by the command show access list, here you can find out, guys, your rules. So your rule 10, so it's like, you know, if we'll take a look for our extended ACL 111, we'll find out here first row permit and how many times it is matched, how many times this rule been used. So it means that one time it made up permission. So in case if I'll try to make one more communication from PC 0 to server 0, then I have to have 2 times of matches. You see, 2 times this rule been worked. Then others get by 1 match, 1 time we used them. And also you have to take a look for this extended IP access list and standard access list, and here we have these rows. We didn't type these numbers 10, 20, 30 and 40, but they are created automatically by the router, so that router is creating the sequence number for each of these rules. And why the sequence number is looking like 10, 20? So we have step of 10, guys, of value 10. So that let me place it here. Just well. And here it is. So that when you are creating an access list and when you are creating some rules, you have step of the sequence between these rules, which is 10. Why ACL is creating such kind of sequence step between the sequences of the rules? Because it's giving you ability to improve your ACL in case if you type it, for example, maybe you mistakenly type it deny any at the beginning, and when you're writing deny any at the beginning, like you are creating access list 10 and you say deny any, or it's going to be access list 11, for example, and then you say access list 11 permit, for example, host, and you are defining host like this, so that your access list will create such kind of sequence. It will say 10 deny any, and then it will create 20 permit and host 10 1 1 1, so that as you see, this rule will always deny any communication. And in case if in future you would like to change your access list, you will be able to use other sequences, for example sequence 1, sequence 2, 3, and here you can use sequence 11, 12. So it is giving you ability to make some changes in the ACL. And when you are having such kind of ability, your ACL is becoming more flexible. So the sequence is created automatically. The step is 10 points, and we have 10 as a step because we can make some changes in future to our access list. I'll show you how to make addition of access list a little bit later. And now, so we have done the first job. It is cool. Now we know what is the extended access list. It can make filtration by source and destination IP address at least. And now it's time to take a look for extended ACL with filtration of port numbers. So before we made up with you filtration only by IP addresses, source and destination. But in next our example, we will make filtration by source IP address, destination IP address, and destination port number. So that in our rules, we have to create, so in our scenario, we have to create an access list which will permit communication from PC0 to contact web server 0. It means that PC0 is able to communicate to server only if it is a web request. Only if it is HTTP request. Alright? And deny PC0 to contact server 0 by other protocols. But by any other protocol, it will not be able to communicate. And permit PC to contact server 1 by all protocols excluding web. And here we have vice versa. PC1 is able to communicate with server 1 by all protocols, so that it can be all protocols, but only deny communication if it is web request. How we can create such kind of access list? So let's take a look for this example. We are creating access list, the same number, access list 111, we are permitting communication. And then look guys, before we used with you IP, but now we are using with you TCP. So if we are using TCP, then at the end of our access list we can use the port number, the destination port number. So we are saying that access list 111 permit TCP communication from computer. So this is PC4, PC0, sorry. It's going to be from and to computer server 0. When it will be, so, and here we have different variants, what we can write here. We can write equal to, which will define that exactly this port. For example, port number 80. When communication will go to port number 80. Or we can say that LT, it's going to be less than. For example, if you'll type LT 80, then it will use all ports from 0 till 79. If you will use greater than, for example 80, then it will use all ports starting from 81 till 65 and 535. And we are saying that only when the communication will go to will be equal to port number 80. So when it will be web request, then it will be successful. And we are saying deny IP, so that IP, it means that including TCP and UDP communication from host 10.4, it's like PC 0 to server 0. Alright, and by the way, we can also attach here the value. So here we can type the row like access list 111, and we can also write deny ICMP from host 192.168.10.4 to host blah 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 and 24. So that ICMP is responsible, as you remember, for such kind of operations like ping, and for such kind of operation like trace route, okay, international communication message protocol. So that we also deny the communication for the ping and trace route between this equipment, so that we are able to check when we will make a web request, it will be successful. When we will make ping, for example, it will not be successful from PC0 to server 0. And the same thing goes to next communication between these equipments. And at the end of this access list, we will also type the same access list 111 deny ICMP, and this will be same and same. And also at the end of this access list, we can write access list 111 deny IP any and any, and for all other IP addresses it will be denied, so that PC1 will not be able to communicate with server 0, and PC0 will not be able to communicate with server 1. So let's try to do this operation, so that we'll go to make configuration of our router 1. So here it is. And first of all, we have to delete our access list. We'll write no access list 111, and then we'll go to and we'll say that also no access list 20, which we created and didn't delete, and we'll go to interface gigabit 00, and we'll say that no access, no IP access group 111 in. And let's check first of all, did we delete all the stuff which is not required to have right now. So our interfaces are empty without any impact of access lists, and we don't have any other access lists. Alright, so then we are ready to make such kind of configuration on router 1. On router 1, yeah. And our first rule will be written like this. Access list 111 permit IP communication from host 192.168.10 and 4 to host. By the way, sorry, it's not just an IP, so we are making permission to web, right? So we are saying TCP, and then we are saying that from host 192.168.10 and 4 and to host 192.168.20 and 4 to define it. And then look, we have here the variants of defining the range or the single port number, destination port number. So that if we'll write equal to, it means that match only packets on given port number. Okay, so that it's quite enough for us to write equal to port number 80, for example. So that we are permitting communication to port number 80 by TCP. And then we are saying that access list 111 deny all other, so that IP from host 192.168.10.4 to host 192.168.24. And so look, when we type at IP at the end of the access list, we are not able to define here our port number. Like in previous example, we had ability to do it. See? Because I used here TCP, and the same thing will be happening if you'll use here the UDP instead of TCP. But with IP, you don't have such kind of ability. And then I can also define that access list 111 deny ICMP, and then from any computer, from 192.168.10 and 4 to host, and here we are typing this from host to host 192.168.20.4, and we can also make filtration, as you see here, echo request, unreachable, and so on, so that we'll just use all ICMP message types. And then we created with you the first rule from our scenario. First row of our scenario is satisfied. Then we have to create another rows which will satisfy second row. So deny PC 0 to contact server 0 by all other protocols. I'm sorry, we already satisfied second row too, and now we have to permit communication from PC 0 to server 1 by all protocols excluding web. Here I had mistake in description, guys, sorry. We don't touch PC 1, we work only with PC 0. It's like this. PC 0 is able to communicate with all protocols, sorry, this is all protocols, and PC 0 is not able to communicate by, so web is not able to be sent. I'm sorry again, and let's continue, guys. So that we are writing permit, or when we have to define only one protocol which is denied, then we have to firstly write deny ICMP, deny TCP communication from host 192.168.10.4 to host 192.168.20.4, and then we are defining equal to 80, and then we are saying access list 111 permit IP from host 192.168.10.4 to host 192.168.20. Oh, what I'm writing, guys? I'm writing the same command. I had to type here only, like, instead of 4, I had to type here 5, so that will it cause the problem? So let me change it now. Deny TCP communication from host 192.168 10 and 4 to host 192.168.20.5 equal to 80, and access list 111 permit IP from host 192.168.10.4 to host 192.168.20.5, and then I also will permit ICMP communication from this host to that host. And then before and also let me go to gigabit 00 interface and implement this access group 111 into like inbound ACL. Before checking this ACL, I have to take a look for access list 111. Here we have such kind of rules. So let me print screen and place it here, so that before I'll check it on an example, I'll check it on by the logic. Well, I hope that everything will be okay. Alright, first thing what will be happening, packet will be checked by using this rule. Permit TCP from host PC0 to server 0 by web. Actually, by the way, we type it here 80, but router say that it is www, because by default port 80 is used by this protocol. And then okay, it is permission. Then our second rule will be deny IP communication from PC4 to 24, from PC 10.4 24. So this will be PC0 is not able to communicate with S0 by other protocols. Then our next rule, so I typed here mistaken rules, so which is denying communication from PC0 to server 0 by web. So I made up deny. But will it impact on the process or not? Let's take a look with you guys. When packet comes and goes from 10.4 to 24 to web, then it is permitted. So that after what, this rule will not be impacted. This rule will not be used, even if it is my mistake, and but this rule will not be used, guys. Why? Because it been used and satisfied for the packet. So that packet which travels from PC0 to S0 by web to web will be permitted, and that's it. So this packet will not go, the router will not search for this rule for that packet, because it is already satisfied and sent. And then our rule, deny TCP communication from 10.4 to 25. So it's like this rule, PC0 is not able to communicate with S1 by web, and next PC0 is able to communicate with S1 with other protocols. So let's try to check it out now, so that we'll go to make test from PC0. We'll try to have access by the web protocol to IP address 20.4. So we have proper access, and now we'll try to make ping from PC0 to server 0, and we'll type here IP address 20.4, which is saying that destination host unreachable. It's not satisfied. So it is good that so if we'll take a look for our scenario, so PC0 can work with server 0 only by web, but not able to communicate with other protocols. Okay, nice. So we can make a web communication as we saw it from here. 20.4. We can do it, but we are not able to make other communication, for example, by ping. It's not working. Next, permit PC0 to contact web server 1 by all protocols, excluding web. But here we have to have vice versa. From PC0, we'll try to make ping to server 1. We are able to do it, you see? We have successful replies coming. But when we'll try to make access by web protocol, 20.5, we will be not, so it will not be successful, due to that fact that we made up these rules. And also I have to mention that extended ACLs have to be placed close to source. So in case if you have such kind of situation, you have your computer, you have your switch, you have your router, and you have here the corporate network, and you have a lot of interconnections between them and so on. Here you have maybe cloud and another computer. So that in case if you are placing extended ACL, it will be better if you place it nearby source. So it will be better to place it here, not at the end of the road. Okay, because when you have extended ACL, you have a lot of filtrations. You have to make filtration from, to, and so on. It will be better if your first router will search for the, it will check is it available to communicate with that equipment or not, so that there is a lot of point of fails for the packet. I mean, if the packet will travel through the extended ACL, and it will be better to prevent routing of this packet in many other routers, so that it will not take a lot of time. It will not take time from those routers. And place standard access lists close to destination. For example, if this is our destination, this is our source, it will be better to place our standard ACL here, because the standard ACL is asking only from where you are coming, so that only the last router will make decision. Are you able to pass or not? It's asking you from where, you say this number and say okay or not. Take in account this information, guys.